We are enhancing the Hungry Traveling Snake project from the WiByte Python curriculum available at www.wibyte.in. In the previous video, we saw how we can create a playing boundary which was square in shape. Now, extending that idea a little bit, in this video, we'll see how we can create a circular playing boundary, which is actually pretty cool. So notice here my playing boundary is like a huge circle. I get my snake head and all these foods. Snake head can move comfortably within this boundary, no problem. It can keep eating the foods as earlier, but the moment it breaches, let's say, the circular boundary, the game, in fact, gets over. So this is pretty cool. We'll see how we do this in a very step-by-step manner and also implement this in code. Now, really, it turns out that there are two possible implementations for this when it comes to a circular boundary. First implementation is really just an extension of the implementation we saw for a square boundary. Basically, we will just get two changes made. We will get the turtle BND to draw a circle. We'll see the radius of the circle in just a moment. Also, we'll have to update the formula to determine if the snake head is inside or let's say it's going out of the circle. This is method number one, quite similar to the previous one that we have done. But there's in fact another interesting method here, which is using turtle shapes and using t dot distance. So the way we will do this is that we will give our turtle BND itself the shape of a circle, make it quite large, and in fact that turtle itself will become the playing area. This is actually very, very interesting. Having done this, we'll just figure out the distance between the snake head and the turtle, and that can be done using t dot distance. So let's look at both these approaches. Let's look at the approach number one first. Remember, we still have to ensure that the foods are all inside the playing area or the circle. In this case, remember the foods are being placed between an area of say minus 200 to 200, and hence we must make sure that the circle is large enough to have all the potential foods. One way to ensure this would be to say that, okay, look, my circle should have a radius which is, let's say, this length, and this radius will be given by 200 times root 2, because that's this by Pythagoras theorem. So I get 200 root 2, which is about 280, and that's what I'll go with. So I'll make a circle of radius 280, and that becomes my playing area. That is definitely large enough to make sure all the foods are in fact inside. Having done this, we must now figure out if the snake is going out. Well, I can use this equation of a circle, which is x square plus y square is equal to the radius square. I can put a condition that if my x square plus the y square, x and y coordinates of the turtle, are becoming more than the radius square, then it means I'm going out. In this case, the radius was 280, but I'm using a number 270 so that the game actually gets over when I just hit the boundary. Recall, my turtle is moving in steps of 20. So if I put 280 over here, really, I'm going to be determining the condition at the next step. So that may make the turtle go out, but 270 is just fine. Having done this, it is quite straightforward. We'll in fact stick with the same code. A food for thought here. Can we extend this idea to other shapes? For example, let's say a triangle, a parallelogram. Think about it. It's quite interesting. A hint for you, we just have to, of course, we have to build this shape, whatever shape we want. And then we need to put conditions that kind of mimic, that kind of reflect the shape that we have drawn, and everything else can remain here. Pretty interesting idea. Very interesting food for thought. Happy to discuss with anybody who's interested. But for now, coming back to the game that we were developing, remember we just want to draw a instead of a, so previously we are drawing, let's say, a circle. I'm sorry, previously we were drawing a square. I'm going to not do that. In fact, maybe we can keep an option to say, okay, circle or square. So we can have both, and depending on a variable, we choose one. But here I'm just going to say, okay, bnd dot, let's say, go to. I'll make it go to, say, for example, 280 and 0, because that's a radius I want. I will set its heading to, let's say, bnd dot set heading to, let's say, 90. So I'll make it go upwards. And thereafter, I will draw, so I'll put the pen down and I'll draw a circle, say bnd dot circle, and I will draw a circle of radius, say 280. And after this, of course, I end the fill, and this should be fairly good to go. Let's see. Notice I get the player boundary being formed, but of course, right now my turtle crashes. Notice this, still crashed here because I still have this condition. If x chord becomes more than 215, or say y chord becomes more than 215, so that's what is going on. But now we need to replace this with the equation of a circle. So I'll comment this out. Actually, I'll copy this over and I will paste this here again, having commented it out. And I'll say, okay, look, if t dot x square chord, let's say, square plus, now be careful on this. This has to be logically correct. T dot y core, let's say, if this becomes more than, let's say, 270 square. Now remember, as I mentioned, I'm keeping this threshold a little bit less than the radius, so it's, it kind of works fine. If this happens, then the game has to get over. Now this star star stands for like squaring, so 270 square and so on. Let's see this working. When I run this code now, notice my turtle is free to move around in the circle. Of course, it can go anywhere, but the moment I touch that boundary, the game gets over. So this is pretty nice. This is my approach number one to having done this. Now let's look at the second approach. This approach basically makes the entire playing area itself a turtle, and that's very interesting. So what I will do is that I already have a sprite called a turtle called BND. Let me give it a shape of circle and let me make it huge, basically make it a radius of 280. If you do this, as we'll see later, you will in fact end up, with the playing area looking a little bit jagged. However, with a little bit more work using this register shape, we can in fact register a perfectly valid circle and give that give the turtle that shape. We'll actually see this later for another, enhancement. And we'll see how it works. But for now, we'll just do this. Basically, we'll create a turtle whose costume is the entire playing area, and this turtle will be placed at 0, 0, and we'll keep it visible. So this becomes interesting. Let's first do this and see what goes on here. I'm not going to touch this part. So I come back here to my code where I was drawing the boundary. Remember, I don't need to draw any more of these. So basically, I will not, let's say, draw any of these things because I want to keep my turtle at 0, 0. So I don't need any of this. What I would do instead is that I'll say, okay, this turtle is not hidden. In fact, I have to show this turtle, which by default it is anyway. And I say bnd dot say shape is, say, a circle. That's the huge circle. And I say bnd dot shape size of, let's say, 28. Now I've done this experimentation to figure out that at this 28 it becomes, this turtle becomes as big as, let's say, this circle. Let's see this working. I'm going to still fill this to, let's say, light green color. When I do this now, in this case, I will see a circle. It looks a little bit jagged, but important to understand that this is now a complete turtle. It's not a drawing by a turtle. In fact, this is a complete turtle. Like I said, we can do more to make this jaggedness go away. We can register a shape to be exactly whatever we want. In fact, this is a powerful idea because we can make compound shapes and we can make those the playing areas. Of course, the condition to determine whether it's the snake head is going out becomes more complicated. So that brings me to the next point, which is, in this case now, how do I figure out if my snake head is going out? In fact, we already saw this working because the condition that worked earlier was to say that, look, if my turtle goes beyond this this circle, I'm out, and that's what is going on right now. But there is one more method we can do this. I can say that, look, if, let's say, t dot distance to, say, b and d is greater than, let's say, 270. Now this is actually very interesting. Remember, the b and d is the entire turtle, which is this playing area. So what we are saying is that, look, if my head goes far away more than 270, it's like saying that I'm measuring the distance of the head from the center of this field of this entire turtle. If this distance becomes more than 270, the game is over. And in fact, we can see this working. This is really quite let's say interesting, I would say, because both are actually turtles, one small, one large, and I can use this concept to make it end the game. In fact, that's exactly what happened, right? So this, remember, the distance works from the center, and we have in fact looked at a video very closely about what distance is. Apply that concept here and it will be very clear. Once again, if learning Python programming this way, by building activities, thinking through them, trying to enhance them, building the enhancements, if this is something that you like, if this way of learning is effective for you, look at our website www.wibyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.